international team led by University of Warwick makes rare sighting of a binary star system heading towards supernova. Astronomers have made the rare sighting of two stars spiraling to their doom by spotting the telltale signs of a teardrop-shaped star. The tragic shape is caused by a massive nearby white dwarf distorting the star with its intense gravity, which will also be the catalyst for an eventual supernova that will consume both. Found by an international team of astronomers and astrophysics led by the University of Warwick, it is one of only very small number of star systems that has been discovered that will one day see a white dwarf star reignite its core. New research published by the team in the journal Nature Astronomy confirms that the two stars are in the early stages of a spiral that will likely end in a type 1a supernova, a type that helps astronomers determine how fast the universe is expanding. HD 265435 is located roughly 1500 light years away and comprises a hot sub-dwarf star and a white dwarf star orbiting each other closely at a rate of around 100 minutes. White dwarfs are dead stars that have burnt out all their fuel and collapsed in on themselves, making them small but extremely dense. A type 1a supernova is generally thought to occur when a white dwarf star's core reignites, leading to a thermonuclear explosion. There are two scenarios where this can happen. In the first, the white dwarf gains enough mass to reach 1.4 times the mass of our Sun, known as the Chandrasekhar limit. HD 265435 fits in the second scenario, in which the total mass of a closed stellar system of multiple stars is near or above this limit. Only a handful of other star systems have been discovered that will reach this threshold and result in a type 1a supernova. Using data from NASA's Transiting Exoplanet Survey satellite TESS, the team were able to observe the hot subdwarf but not the white dwarf, as the hot subdwarf is much brighter. However, that brightness varies over time, which suggested the star was being distorted into a teardrop shape by a nearby massive object. Using radial velocity and rotational velocity measurements from the Palomar Observatory and the WM Higgs Observatory, and by modeling the massive object's effect on the hot subdwarf, the astronomers could confirm that the hidden white dwarf is as heavy as our Sun, but just slightly smaller than the Earth's radius. Combined with the mass of the hot subdwarf, which is a little over 0.6 times the mass of our Sun, both stars have the mass needed to cause a type 1a supernova. As the two stars are already close enough to begin spiraling closer together, the white dwarf will inevitably go supernova in around 70 million years. Theoretical models produced specifically for this study predict that the hot subdwarf will contract to become a white dwarf star as well before merging with its companion.